In this video, I finally get to make an animation concept I've wanted to try for years. Welcome back to my studio. Today is very special because I finally have my very own motion capture suit. It is a suit that has a bunch of sensors everywhere, so I can move my arms and legs around. It even has finger tracking, so I can put this on my body and I can create a digital double of myself and see how that looks in real time. So this is the Smart Suit Pro 2 by Rococo. They sent me this suit, so this video is sponsored by Rococo. I have so many ideas and I can't wait to put this on. I think I have another camera somewhere. Yeah, hello, there we go. So if I strap this camera to my head, look at this setup. I am the technology. So now we're set up. I can walk around in my studio. Yeah, this is my studio, by the way. Here I have my piano, I have my guitar, I have my computer. I have this one, the BB-8 that my girlfriend made me. I love this so much, look at that. And then here you can see I have my cable management. The thing is, I managed to connect all the cables. My camera, microphone, I love it here. I also have my TV with 5.1 surround. I love this place, I love it so much. Anyways, I think I should be able to record some motion capture here. So let's try and connect this to the computer. I'm gonna take this in here. And this one in here. And then I have my power bank, which I will also connect. Like this. So now I have this armor. Oh, and there is the suit connected. Wow, look at it. Look at how crazy this looks. I've never had this much technology on my body before. It feels very good. Oh, that's me. Yeah, I probably need to calibrate this. Look at the fingers are working already. Okay, so let me calibrate pose here. Hey, nice. Wow. Look at that. That is phenomenal, actually. The fingers move as well. So it's streaming in real time. Hang on. That's so weird. It only has one sensor, but it still knows if I'm bending this or if I'm... I just don't understand how that works. Okay, I just want to try something. I'm gonna hit record here. And I just want to tip over a bunch of objects. So if I'm walking around looking like this and just boom, and then boink. I wonder what that would look like. Look at that. Let me full screen this. That is a beautiful pose. Okay, nice. That's actually kind of funny. I can export it as an FBX format, so I'm going to do that. Okay, so I'm using Blender 4.4. I'm going to import this FBX file and let's have a look. Okay, wow, look at that. That is very intense. Oh, okay. So we need to find where are the hits. We have one like here, and then we have here, and then we have the double push here. Just do this, so I know where they are in 3D space. And then we have the kick, which is there. That face, look at that face though. And there's the kick. Okay, so now we have these 4 points in 3D space of where we need to place these cubes for it to be impacted with our motion capture here. So let's just make some cubes. Maybe this is a good size. So we want to place these cubes here, 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 and here. And then I just want to duplicate them. So now if we turn this into a rigid body simulation, I'm going to give these physics. And you know what? I don't want to use this mesh to interact with the physics. I want to create some dummy objects because that's just much more reliable. So let's just add a sphere and then we stretch it a little bit and just place it inside the hand. And then if you take one of these bones, we can just parent it to that bone. So now we have this object here connected to the hand. See that? It's following. So it should interact with the cubes here. So let's see. Nice. So now let's just duplicate this and move it to the hand and legs. Like that. And I also want to have some bevel on these cubes, just so it's a little bit easier to see that they are actually cubes stacked on top of each other. So let's have a look at this. We punch the first tower, nice. Oh, it even falls over. And then this one, the slap. And the double one, the kick. Let's see it. Nice. You know, I think I want to create my own model. Maybe like a cool helmet or something. But it's so much work to model a robot. Okay, here's what we're gonna do. I'm gonna put on some music and I'm just gonna model it in my own pace. So please enjoy a time lapse of me modeling a robot. Okay, so the robot design is finished. It is heavily inspired by the Mixamo Y-bot, but I wanted to have more of like a low poly look and also a little bit more robotic with like a helmet. But then if you zoom in and you can see up close there, you can see that there is this circuit board texture, just to ground it a little bit more in the technology. I found this circuit board generator. It's a CodePen project by Ben Matthews. And here you can see you can change all these settings up here. So you can basically create your own custom circuit boards. So when you're happy about your values, you can just save it as a PNG. So here you can see I just mapped that circuit board texture to the body, and then I isolated the colors from it. And then I also added this reflection part of it. So you can see it's kind of highlighted with some circuit board texture. And then on the helmet, I created a texture for this visor. This is actually a fully procedural texture. So if you pay attention to this grid pattern here, I can change this and you can turn it into more of an organic pattern. And I thought this could be really cool if you wanted the robot to come alive, sort of. And then the overall body shader is like this subsurface scattering shader here. So if you move the lighting around, you can see it does actually have some translucency, which I think is a really cool effect. You can see that the visor is lighting it up and this circuit board texture is coming through a little bit. So I really like that. So let me show you a little bit more of an advanced scene I set up. Here you can see you have this robot that is kind of just walking slowly towards the camera. And with the correct set of lighting, it kind of turns into this super cinematic vibe. So this is basically a really narrow lamp that is kind of being animated across. Here you can see it's kind of moving across the face like this. Look at that. It starts out with a grid pattern and then it transitions into this more dynamic and it kind of feels more evil. So yeah, that is my robot design that hopefully works when you're looking at it far away. And when you zoom in, you're also satisfied by this level of detail with the circuit board and the visor with the texture here. So now we have our robot design and the workflow just works. I want to try an idea I've had for years. And it's a twist on a concept I've done before actually, but I think it will be very interesting with this motion capture workflow that we have here. So you know this pendulum wave effect? If you have a bunch of pendulums swinging back and forth and their strings have different lengths, you get these really interesting patterns that emerge as the pendulums clump up and separate. So if you fast forward here, for example, you can see that they kind of sync up and create these patterns. And then as we get closer to the end here you can see they will all sync up, and eventually it's a perfect loop. So I was thinking, what if instead of pendulums going back and forth, it's me, and I'm the robot, and I have the motion capture suit, and I can walk back and forth, and let's say every time I turn, I play a note with like a mallet. So I can walk back and forth, and I can do like this, doink, and I can play like a note. And I'm just so interested to see, will that work? What would it look like if you have humanoid movement instead of this perfectly sine wave motion like this? So I'm going to put on the motion capture suit again and see if this works. Okay, so I have this Harry Potter wand, and it's quite heavy here. So I should be able to use this like a mallet that actually feels heavy. It's different if I just do it like this. Kind of tough to nail it, but if I have actual weight in my hand, it just feels more real, I think. So let's calibrate and let's do a recording. So I'm gonna go over here, and then over here, and then back again. And I'm gonna try and loop this. I need to be wary of where I place my feet. Okay, so let's have a look at the recording. Okay, I need to be able to loop this. I need to be wary of how my feet are placed. Look at that. That might be easy to loop, yeah. Doink. Doink. Okay, sweet. Yeah, I think I'm happy about this. Now let's import this to Blender and let's see what we have to work with. So here we are back in Blender. We have our PolyBot model, and we also have a mallet object that I've made here. So we're gonna take this and put it in his hand. If you could hold this for a second. Let's see here. Oh, yes. So one hit and then he walks over. Great, okay, nice, it works. So we want to loop this. But instead of looping it right here, I think that's a little bit too sensitive, too much motion there. So I want to loop it here in the turn here. So let's set the first frame here, and then let's move forward and let's set the last frame just here. Okay, so here we have the first frame, last frame, first frame, last frame. So the goal is to just morph between these two. Here you can see we have the section that we want to loop. If you really think about it, that means we don't need any of the data outside of here. So we can just box select our keyframes, and then Control I, select inverted, and just get rid of everything else. So these are all the keyframes we need. So let me just duplicate this, and then I want to line this up. And here you can see, we want to line it up here maybe? Yeah. So now we can see that we have our loop here instead. So now we can smooth these keyframes. The last frame should be here. I think that is a pretty good loop. Yeah, look at that, because we're cutting exactly in the movement. Just feels really fluid, doesn't it? Oh, by the way, now you can see that if we extend our timeline, we no longer have a looping animation. So I'm just going to add a cyclic modifier. So now we have an animation that will loop forever, regardless of the duration of our timeline. So now that we have our animation, if you really think about it, this is the first pendulum. Look at this. On frame 1, we have a hit over here. And then we move all the way over here, hit there as well. And then we move back again. And on frame 173, we have made one oscillation. It goes back and forth in 173 frames. Oh wait, look at this. Our animation is actually almost 180 frames. That would be so nice. Because if you do some simple maths here, I'm working at 30 frames per second. So if we are at 180 frames, you can see that is exactly 6 seconds. So that means that our oscillating pendulum will do 3 seconds per swing, basically. That would be a lot easier to work with. Yeah, so I'm actually just going to time stretch this animation just a little bit. So let me just scale this up here. Let me just see. I just want this to be really precise. Okay, so now we have a perfect 180 frames loop, and we are ready to start duplicating our robot here. So I'm just going to duplicate my robot on the y-axis, and then I'm just going to make a bunch of copies. Okay, so now we have these 8 robots here, and they're basically behaving like pendulums at this point, because they are oscillating back and forth 10 times in 1 minute. But we don't want them all to be synchronized, we want everyone to walk at a different tempo. And specifically, we want our first robot to oscillate 10 times per minute. And then we want the second robot to oscillate 11 times per minute, and the third one 12 times, etc. Now let's just think about this for a second. That is just so extremely difficult to animate. Like, we have so many keyframes, and then we need to time stretch that, and it's such a headache to try and figure it out. So instead of us sitting here having a horrible time trying to figure out all the math behind this, why don't we use the pendulum wave calculator? I've been working on this for so long, and I'm really excited about it. It's such an over-engineered solution to a very niche problem. Let me show you how it works, because it's so powerful. So if you press play, you can see this pendulum oscillating back and forth. So if you set the swing duration to, for example, 6 seconds, then the swing per loop updates. How cool is that? So now the pendulum will use 6 seconds on one full swing. But here's the cool part. You can add more pendulums. So if you, for example, add, so we have 8 pendulums here. Now you can see what this is going to look like. You can even see how long it is until the loop restarts. So here you can see if you go halfway, for example, you get this pattern. You can basically just see when in this animation are there going to be interesting patterns. And then when you get to the end, it just loops seamlessly. Yeah, so there are some advanced features here. I'm not going to be able to go through all of them, but basically you can use this tool to preview what your animation is going to look like. Okay, now this is where things get really interesting. Let's try and recreate the scene we have in Blender with the pendulum wave calculator. So we're working in 30 frames per second. So let's set our frame rate here to 30 frames per second. So now you can see the swing duration changes to frames instead. And we have a 180 frames long animation. So let's just set this to 180 frames. And now if you press play, you can increase the number of pendulums. And you can see that if you set it to 8 pendulums, this is what our animation is going to look like. And now let me show you the coolest part. And I am so happy about this. I spent ages making this work. If you zoom out, or if you scroll down, look at this. There is a button. If you click this button, you get the possibility to generate a Python script, which just animates your entire scene for you. How cool is that? I am so happy about this. I spent ages making this. So let's just delete all the robots here. And let's take our robot here, and we can see it's in a collection. So I'm going to copy this name. And in this source collection name here, you want to input the name of your collection. So I'm just going to call this PolyBot because that is the name of our collection. And then you can click Generate Python Script, and then copy script to clipboard. And then in Blender, I'm just going to open a new viewport here and set it to Text Editor, New. And then you just paste the script, and you don't have to do anything else. That is it. Because now when I press play, it will duplicate, it will time stretch, it will do everything. And look at that. It has even changed the duration of our animation. Look at that, 1800 frames. That is the loop duration. So this means that now we have a fully looping pendulum animation where every person that is walking is a pendulum. And we get these beautiful patterns. And you can see if we go halfway, we have a symmetrical that looks like this. You can go halfway here and see, it looks like this. Symmetrical like that. Look at that. That is so cool. Isn't that just amazing that this web app just does everything for you? You don't have to do any math, and oh, I spent so much time on this. It's such a cool web app. Yeah, if you want to try it, you can go to tools.polyphore.com. It's just a free web app. I've also posted it on GitHub if you want to help improve it, because it's GPL and open source. So now we have this pendulum wave effect, but it's robots. And they're walking back and forth. Look at this when they turn here. They all know what they're supposed to do, you know? And look at this, the loop is absolutely seamless. Look at this. That is amazing. Oh, I forgot to add the instrument. They're gonna play something, right? I'll just make a simple like this. Wait, what's the... I offset this by, yeah, 0.7 meters. Yeah, so if I just duplicate this, 0.7 meters. And then let's do the other side. Okay, so now that we have all these mallets hitting all these bars, and they're hitting them at different time intervals like this, we need to add one instrument sound on every hit, for every mallet, for every speed here. It's gonna take forever, right? I mean, what if there was a way to make it a little bit faster? Wouldn't that be nice? If you scroll all the way down, there's a button. You can see that you can export this animation data as a MIDI file. So let's see here. Here you can see it automatically calculates the BPM based on the swing duration and the loop duration. And you have the number of notes, which is the number of pendulums. And you can even change the chord type. So let's just click generate and download MIDI. So let me put these on. And now here I am in Reason 13, where I can import the MIDI file. Just click and drag it in there. And now if we zoom in here, we can see that we have the notes being played. It just works. Amazing. Let me just clean this up. I'm going to change the instrument. Maybe something bell-like, like this. Oh, nice. Let's go down an octave. Yeah, let's even go down one more. Turn on some reverb. Oh, nice. That's beautiful. Look at this beautiful pattern here. That is crazy. So I'm just going to export this as an audio file. C minor 20 beats per minute. So now let's import this audio file to Blender. And let's see, it should sync up just right away. That is amazing. That is so cool. Let's go to the middle here and see. There's this big spike here. I think that will be quite epic. Let's have a look at this. Oh, okay, I'm going to render this out as a final animation with the texture and everything. If you watch this entire video, I appreciate that. Maybe even give it a like if you thought it was interesting. And yeah, please enjoy the Humanoid Pendulum. Big thanks to Rococo for sponsoring this video and for sending me the motion capture suit. I've had so much fun with this over the past few weeks, so check out the link in the description to learn more. Thanks for watching.